Look up at the night sky for a moment. Every tiny point of light you see is a star. Many of those stars are older than our sun. Many of them have planets. In fact, modern astronomy tells us something astonishing. Our galaxy alone contains roughly 400 billion stars, and around most of those stars there are planetary systems. That means there may be trillions of planets orbiting suns across the Milky Way. Some of them are rocky worlds like Earth. Some may have oceans, atmospheres, and the right temperatures for life. Now think about time. The Milky Way has existed for more than 10 billion years. Earth formed only 4.5 billion years ago, and human civilization has existed for just a tiny fraction of that time. In cosmic terms, we arrived incredibly late. If life can arise on planets and evolve toward intelligence, then somewhere in those billions of star systems, civilizations should have appeared millions or even billions of years before us. They would have had unimaginable time to develop technology, explore the stars, and spread across the galaxy. And yet when we look into space, we see something deeply unsettling. No alien signals, no star-spanning empires, no probes, no visitors, just silence. A silence so vast that it leads to one of the most disturbing questions ever asked in science. If the universe should be full of life, where is everybody? To understand why this question is so unsettling, we need to think about the sheer scale of the galaxy we live in. The Milky Way is not a small place. It is a vast rotating disk of stars, stretching roughly 100,000 light years from one side to the other. Inside this enormous structure are around 400 billion stars. For most of human history, we didn't know whether planets were common or rare. But modern astronomy has answered that question. Using telescopes like Kepler and other planet-hunting missions, we now know that planetary systems are not unusual accidents. They appear to be the rule. Most stars seem to have planets orbiting them. If you do the arithmetic, the result is staggering. Hundreds of billions of stars means potentially trillions of planets scattered throughout our galaxy alone. Among them must be countless rocky worlds, some orbiting at just the right distance from their stars, where temperatures allow liquid water to exist on the surface. Astronomers call this region the habitable zone. Earth happens to sit comfortably inside that zone around our sun, and because of that simple fact, our planet has oceans, weather, and a stable environment where life could emerge. Now imagine repeating that situation not once, but millions or even billions of times across the galaxy. Even if only a tiny fraction of planets are suitable for life, the numbers still become enormous. If just 1 in a million planets develops biology, that would still leave thousands of living worlds in the Milky Way. And if even a small percentage of those planets eventually produce intelligent beings capable of building technology, then civilization should not be rare events. In fact, by the logic of these numbers, the galaxy should already be full of them. But the real twist comes when we think about time. The Milky Way is more than 10 billion years old. Our solar system is only about 4.5 billion years old, meaning the galaxy had already existed for billions of years before Earth even formed. That means if intelligent civilizations ever appeared somewhere else, many of them could have arisen millions or even billions of years before humanity. And that difference in time matters enormously. A civilization with even a million-year head start, an almost trivial amount on cosmic timescales, could develop technologies far beyond anything we can imagine today. Given enough time, such a civilization might spread from star to star, exploring neighboring systems, and gradually expanding outward across the galaxy. In other words, if intelligent life is even moderately common, the Milky Way should already be buzzing with activity. Civilization should have arisen long before we appeared, and their presence should be visible everywhere. And yet, when we look out into the cosmos, we see nothing that clearly indicates another technological species, no interstellar empires, no alien signals strong enough to detect, just a quiet, ancient galaxy filled with stars. And that silence leads directly to the strange and famous question that physicist Enrico Fermi once asked. If the universe is so full of possibilities, where is everybody? The mystery we are talking about today has a surprisingly simple origin. It did not begin with a complicated equation or an elaborate scientific theory. It began with a casual conversation during lunch. In the early 1950s, the legendary physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. Fermi was not just any scientist. He was one of the giants of 20th century physics, a Nobel Prize winner whose work helped shape nuclear physics, quantum theory, and the first nuclear reactor. He was known for having an extraordinary intuition about numbers and probabilities. During that lunch conversation, the group began discussing flying saucers and the possibility of extraterrestrial life. The topic was speculative, even a bit playful. But Fermi suddenly stopped the conversation with a simple question. He asked, "Where is everybody?" That was it. No equations, no long explanation, just 4 words. At first glance, the question sounds almost trivial, but once you begin to think about it seriously, it becomes deeply unsettling. Fermi's point was not about UFO sightings or science fiction stories. His point was about mathematics and probability. If the galaxy contains hundreds of billions of stars, and if many of those stars have planets, then the chances for life to emerge somewhere should be extremely high. Given enough time, some of that life should evolve intelligence. Some intelligent species should eventually develop technology, radio transmitters, spacecraft, perhaps even the ability to travel between stars. And if even a single civilization achieved interstellar travel millions of years ago, it could gradually spread through the galaxy. It would not have to do it quickly. Even slow exploration, moving from one nearby star system to the next, could eventually reach every corner of the Milky Way. The galaxy is enormous, but it is also very old. Over millions or billions of years, the spread of a technological civilization might be inevitable. Which leads to the paradox. If intelligent civilizations are common, the galaxy should already be full of them. We should see evidence everywhere. Signals, spacecraft, artificial structures, or at the very least some unmistakable sign that we are not alone. But when astronomers search the sky, they find nothing that clearly proves another technological species exists. No confirmed alien transmissions, no probes entering our solar system, no ancient galactic civilizations leaving visible traces across the stars. The universe appears strangely silent. This contradiction between what we expect to see and what we actually observe became known as the Fermi Paradox. It is not really a paradox in the logical sense, but it captures a profound puzzle. The galaxy seems full of opportunities for life, and yet there is no clear evidence that anyone else is out there. So the question remains, just as Fermi asked it decades ago, if intelligent life should be common in the universe, why do we see no sign of it at all? One possible answer to the Fermi paradox is both simple and unsettling. Perhaps intelligent life is not common at all. Perhaps planets like Earth are extraordinarily rare. At first, this idea sounds strange. After all, we now know that planets are everywhere. Astronomers have already discovered thousands of worlds orbiting distant stars, and the evidence suggests there are billions more waiting to be found. But having planets is not the same thing as having a planet like Earth. For life to develop into something complex, a planet must satisfy a long list of conditions. It must orbit its star at the right distance so that temperatures allow liquid water to exist. Too close and the oceans boil away. Too far and the planet freezes into a lifeless ice world. This narrow region around a star is known as the habitable zone. Earth sits comfortably inside it, but that alone is not enough. The planet must also have a stable orbit that does not swing wildly over time. Its parent star must be reasonably calm and long-lived. Some stars flare violently, blasting nearby planets with radiation that could sterilize any developing life. Others burn through their fuel too quickly, dying long before life has time to evolve into anything complex. Our sun, by contrast, is remarkably stable and expected to shine for billions more years. Even that may not be sufficient. Earth also has a large moon that helps stabilize the tilt of our planet's axis. That stability may be important for maintaining long-term climate patterns. Our solar system also contains giant planets like Jupiter, which may act as gravitational shields that reduce the number of catastrophic asteroid impacts reaching Earth. But perhaps the most important requirement of all is something we rarely think about: time. On Earth, life appeared very early in our planet's history. The oldest evidence suggests that simple microorganisms existed around 3.8 billion years ago. But those early organisms were extremely simple, single cells drifting through ancient oceans. And then something remarkable happened. Or rather, something remarkable took an incredibly long time to happen. For nearly 3 billion years, life on Earth remained mostly microscopic. Bacteria and simple cells dominated the planet for the vast majority of its history. Complex organisms did not appear until relatively recently in geological terms. Only in the last billion years did multicellular life begin to flourish. From there, the process accelerated. Plants, animals, ecosystems, intelligence, and eventually human civilization. When you step back and look at that timeline, a startling fact emerges. It took roughly 4 billion years for life on Earth to evolve from the simplest cell to a technological species capable of building rockets and radio telescopes. That is almost 1/3 of the age of the universe itself, which raises a troubling possibility. Perhaps many planets do develop life, but their environments do not remain stable long enough for that life to become intelligent. Catastrophic events, stellar explosions, climate collapse, massive asteroid impacts might repeatedly reset the evolutionary clock. If that is true, then Earth may not simply be another habitable world. It may be one of the very few places in the entire galaxy where the chain of life has remained unbroken for billions of years, long enough for cells to slowly become civilizations. To understand how unusual Earth might be, we need to remember something important about the universe. It is not a calm or peaceful place. On human timescales, the night sky appears stable and eternal. But on cosmic timescales, the universe is violent, chaotic, and full of catastrophic events. Stars explode. Asteroids collide with planets. Entire solar systems are reshaped by gravitational disturbances. Radiation bursts across space with enough power to sterilize entire worlds. The cosmos is constantly changing, and most environments within it are far from gentle. For life to evolve into something complex, a planet must survive billions of years without being completely wiped out. That sounds simple, but it is actually an extraordinary requirement. Consider supernova explosions. When a massive star reaches the end of its life, it can explode with unimaginable energy, briefly shining brighter than an entire galaxy. If such an explosion occurs too close to a habitable planet, the radiation could strip away its atmosphere or destroy its protective ozone layer, exposing the surface to lethal ultraviolet radiation. A single nearby supernova might be enough to reset the entire evolutionary history of a world. Then there are asteroid impacts. Earth itself has experienced many of these throughout its history. Around 66 million years ago, a large asteroid struck our planet and triggered the extinction of the dinosaurs. That impact changed the course of evolution, clearing the way for mammals and eventually humans to dominate the planet. But that asteroid, destructive as it was, did not wipe out life completely. The chain of life continued. Microorganisms survived. Plants recovered. Ecosystems slowly rebuilt themselves. Life on Earth endured. Now imagine a much larger impact. A collision large enough to boil the oceans or strip away the atmosphere could erase life entirely. If that had happened at any point during the last 4 billion years, the evolutionary story of Earth would have ended before intelligent beings ever had the chance to appear. Remarkably, that never happened. Our sun has also been unusually stable. Many stars fluctuate dramatically, releasing powerful flares and bursts of radiation. The sun does change over time, but not violently enough to sterilize Earth. Over billions of years, It has provided a steady flow of energy, enough to sustain life, but not so extreme that it destroys it. And our location within the galaxy may also be fortunate. The Milky Way contains regions where stars are packed closely together, where supernova explosions are more common, and where gravitational disturbances are stronger. Earth happens to orbit in a relatively quiet part of the galaxy, far from the chaotic center where conditions are far more dangerous. All of these factors may have contributed to one extraordinary outcome, an unbroken chain of life lasting nearly 4 billion years. That continuity is the key. Evolution does not happen overnight. The journey from simple cells to complex organisms and eventually to intelligence requires immense stretches of time. If that chain is broken even once, the process must begin again from the very beginning. So perhaps the reason we do not see countless alien civilizations is not because life never starts. Perhaps it starts often, but almost always gets interrupted before it has time to become intelligent. In that case, Earth may not simply be lucky. It may be astonishingly lucky. Another possible answer to the Fermi Paradox is far less dramatic, but still deeply important. Perhaps intelligent civilizations do exist throughout the galaxy, but the distances between stars are simply too vast for us to notice them. Space, after all, is unimaginably large. Even the nearest star system to Earth, Alpha Centauri, is more than 4 light years away. That means the light we see from it tonight actually left that star more than 4 years ago. Traveling there with our current spacecraft would take tens of thousands of years, and Alpha Centauri is practically our neighbor. Now imagine scaling that distance up to the size of the entire Milky Way. Our galaxy stretches roughly 100,000 light years across. Between most stars lie enormous regions of empty space. Even moving at extraordinary speeds, crossing those distances becomes a monumental engineering challenge. Because of this, it is possible that civilizations may exist but remain isolated within their own star systems. They may develop technology, build telescopes, and perhaps even send signals into space, but those signals weaken rapidly as they travel. Radio waves spread outward in every direction, and the further they go, the more diluted they become. By the time they reach another star system, they may be far too faint to detect. The same problem applies to spacecraft. Interstellar travel is not impossible according to the laws of physics, but it is incredibly difficult. Building a spacecraft capable of surviving decades, centuries, or even millennia in deep space would require technology far beyond what we currently possess. Even if such ships could be built, the cost and effort might be enormous. A civilization might explore nearby stars but find it impractical to spread across the entire galaxy. In that case, the Milky Way could contain many intelligent species, each separated by such immense distances that they rarely, if ever, encounter one another. Entire civilizations might rise and fall without ever realizing that others existed somewhere else in the galaxy. But there is a problem with this explanation. Even if direct travel between stars is difficult, there are other ways a civilization might explore the galaxy. Instead of sending living beings across interstellar space, they could send machines. Machines do not need oxygen, food, or comfortable environments. They can endure long journeys and operate for centuries if designed correctly. And if those machines could build copies of themselves when they reach new star systems, the process could spread outward faster and faster. This idea leads to one of the most fascinating arguments connected to the Fermi Paradox, an argument suggesting that if any civilization ever reached a certain technological level, the entire galaxy could eventually become filled with its machines. And yet once again, when we look into the cosmos, we see no evidence that this has ever happened. At this point in the puzzle, many scientists begin to ask a very different question. Instead of asking whether civilizations can travel across the galaxy, we might ask something simpler. Do they even need to? Imagine you are part of an advanced technological civilization. Your scientists have mastered artificial intelligence, robotics, and space engineering. Instead of sending fragile biological beings on dangerous interstellar journeys, you decide to send machines. These machines are small, autonomous probes designed to explore nearby star systems. Now imagine giving those probes one additional capability. When they arrive at a new solar system, they can use local materials, asteroids, metal-rich rocks, or planetary debris to build copies of themselves. Once the copies are built, each one travels to another nearby star system and repeats the process. What you have created is known as a self-replicating probe, sometimes called a von Neumann machine, named after mathematician John von Neumann, who studied the idea of machines capable of reproducing themselves. The implications of such machines are extraordinary. Suppose your civilization launches just one successful probe. It travels to a nearby star system and builds 2 copies of itself. Those 2 probes then travel outward and each produce 2 more. Soon you have 4 probes, then 8, then 16, then 32. This process is called exponential growth. And exponential growth has a remarkable property. It starts slowly, but eventually becomes incredibly fast. Even if each probe takes thousands of years to travel between stars and replicate itself, the numbers would still grow rapidly over cosmic timescales. In a relatively short period, perhaps 10 million to 100 million years, these machines could spread from star to star until they had visited every corner of the Milky Way. That might sound like an enormous amount of time, but in the lifetime of a galaxy, it is actually very small. Remember that the Milky Way is more than 10 billion years old. 100 million years is just a brief moment in comparison, which leads to a striking conclusion. If even one civilization anywhere in the galaxy had ever developed this technology millions or billions of years ago, then its machines could already have spread across the entire Milky Way. Probes might be orbiting stars everywhere. Some might even be quietly sitting inside our own solar system, monitoring planets like Earth. But once again, when astronomers search the skies and examine our cosmic neighborhood, they find no clear evidence of such machines. No alien probes visiting our planets. No artificial structures surrounding distant stars. No unmistakable signs that an ancient technological civilization has explored the galaxy before us. And that deepens the mystery. Because if a single civilization could fill the galaxy with machines in a relatively short time, and if the galaxy has existed for billions of years, then the absence of those machines suggests something unsettling. Perhaps no civilization has ever reached that level of technology, or perhaps something stops them before they ever get the chance. There is another possibility, one that is both fascinating and slightly disturbing. Maybe the galaxy is not empty at all. Maybe advanced civilizations are out there, watching, listening, perhaps even exploring, but they are choosing to remain silent. This idea is sometimes called the dark forest hypothesis. The name comes from a simple metaphor. Imagine walking alone through a dark forest at night. You know there may be other hunters out there hidden somewhere among the trees. You cannot see them, and you do not know whether they are friendly or hostile. In that situation, the safest strategy is not to shout and reveal your location. The safest strategy is to remain quiet and hidden. Applied to the galaxy, the logic becomes unsettling. If intelligent civilizations exist, they might assume that other civilizations could be dangerous. Any species capable of traveling between stars might also possess technologies powerful enough to destroy entire planets. If that is true, broadcasting your location to the universe could be incredibly risky. A civilization that values survival above all else might decide on a simple rule: stay silent and stay hidden. If every advanced civilization comes to the same conclusion, then the galaxy could be full of intelligent life, yet still appear completely quiet from our perspective. Everyone would be listening, but no one would be speaking. From that point of view, the silence of the cosmos would not mean we are alone. It would mean that every civilization has learned the same lesson, that revealing your presence might be the most dangerous thing you could do. What makes this idea particularly interesting is that humanity has done almost the opposite. Since the middle of the 20th century, we have been broadcasting radio signals into space. Television transmissions, radar systems, and powerful communication networks all leak signals outward from Earth. Some scientists have even deliberately sent messages intended for extraterrestrial civilizations. One famous example is the Arecibo message, transmitted in 1974 toward a distant cluster of stars. It was a symbolic attempt to announce our presence to the cosmos. Spacecraft such as the Voyager probes also carry plaques and golden records containing information about our planet and our species, designed in case another civilization ever finds them. In other words, humanity has not tried to hide. If anything, we have been eager to say hello. But perhaps more advanced civilizations would behave differently. Perhaps they would be wiser or more cautious. They might decide that survival depends on remaining invisible in the cosmic wilderness. If that is the case, then the silence of the universe may not be a mystery at all. It may simply be the sound of countless civilizations choosing not to be heard. Among all the explanations for the Fermi Paradox, one idea stands out as particularly unsettling. It is known as the Great Filter. The concept is simple but profound. Somewhere along the long path from simple chemistry to an advanced interstellar civilization, there may be a barrier, a stage that almost no species ever manages to pass. That barrier is the Great Filter. To understand what this means, think about the chain of events required for a civilization like ours to exist. First, a planet must form around a star. Then, chemistry must organize itself into the first self-replicating molecules. Those molecules must eventually evolve into living cells. Over immense spans of time, simple organisms must become complex ones. Intelligence must arise. Technology must develop. Finally, that technological civilization must survive long enough to expand beyond its home planet and reach the stars. Each step in this chain may be extremely unlikely. If even one of these steps is extraordinarily rare, then the number of civilizations that reach the final stage could be extremely small. The Great Filter could lie in our past. If that is the case, then humanity has already passed the most difficult steps. Perhaps the origin of life is incredibly rare. Perhaps the transition from simple cells to complex multicellular organisms almost never happens. Or perhaps the emergence of intelligence is a biological accident that occurs only once in billions of planets. If the filter is behind us, then we may simply be very lucky. Life on Earth managed to pass through a series of improbable evolutionary steps that almost never succeed elsewhere in the universe. But there is another, far more troubling possibility. The Great Filter might lie ahead of us. In that case, civilizations may commonly reach a stage similar to where humanity is today. They develop science, industry, and powerful technology. They build energy systems, communication networks, and advanced weapons. But before they can spread beyond their home planet, something goes terribly wrong. A civilization might destroy itself through nuclear war. It might destabilize its climate and collapse its own ecosystem. It might create biological weapons or uncontrolled artificial intelligence. Technological power may grow faster than wisdom or political stability. If that happens often enough, then most civilizations would extinguish themselves before ever becoming interstellar species. They would appear briefly in the cosmic timeline rising, flourishing for a short period, and then disappearing forever. This possibility is deeply unsettling, because we can already see some of those dangers around us today. Humanity possesses nuclear weapons capable of devastating entire continents. We face environmental challenges that threaten global stability. Emerging technologies, from biotechnology to artificial intelligence, hold immense promise, but also enormous risk if misused or poorly controlled. In other words, we may already be approaching the stage where the Great Filter operates. If that is true, then the silence of the galaxy might not mean that intelligent life is rare. It might mean that civilizations tend to destroy themselves before they ever reach the stars. There is one final possibility that some scientists quietly consider when thinking about the Fermi Paradox. It is not the most dramatic explanation, and it is not the most comforting either, but it may be the simplest. Perhaps the reason the universe appears silent is because intelligent civilizations are extraordinarily rare. perhaps so rare that in an entire galaxy like the Milky Way, there might be only one, us. This idea does not mean that life itself is impossible elsewhere. In fact, many scientists suspect that simple life microbes, bacteria, or primitive organisms may exist on many worlds. There are places, even within our own solar system, where microbial life might survive. Mars once had rivers and lakes. Europa and Enceladus hide vast oceans beneath their icy surfaces. Even distant moons and dwarf planets may contain pockets of liquid water beneath frozen crusts. Microbial life might be common in the universe, but the step from simple microbes to complex organisms may be incredibly rare. On Earth, one of the most important turning points in evolution was the emergence of eukaryotic cells, cells with complex internal structures and a nucleus. These cells form the basis of all complex life on our planet: animals, plants, fungi, and ultimately humans. What makes this event remarkable is that, as far as we can tell, it happened only once in the entire history of life on Earth. Every complex organism alive today descends from that single evolutionary breakthrough. If that transition required a very unlikely combination of circumstances, then complex life may be rare even on planets where simple life exists. And if complex life is rare, intelligent life may be rarer still. From that perspective, a galaxy filled with billions of planets might still contain very few civilizations, perhaps even fewer than one on average. Some galaxies might have none at all. Others might have a single intelligent species appearing briefly before disappearing again. If that is the case, then the Milky Way could be a vast cosmic ocean of stars, planets, and microbial life, yet contain only one civilization capable of asking questions about the universe. That possibility carries an enormous implication. If we truly are the only intelligent civilization in this galaxy, or even one of only a few, then the future of intelligence in the Milky Way may depend entirely on what happens here on Earth. Our planet would not simply be another inhabited world among billions. It would be something far more precious. It would be an island of meaning in a vast sea of stars. And that realization places an extraordinary responsibility on us. Because if we destroy our civilization through war, environmental collapse, or simple negligence, we might not just be ending a chapter in human history. We might be extinguishing the only voice of intelligence in an entire galaxy of 400 billion suns. Of course, this is only a hypothesis. Scientists would be thrilled to discover that it is wrong. The day we detect a signal from another civilization or encounter evidence of life far beyond Earth will be one of the greatest discoveries in the history of science. But until that day arrives, the silence of the cosmos leaves us with a haunting question. Maybe the universe is not full of civilizations waiting to be discovered. Maybe it has been waiting for one civilization to survive long enough to reach the stars.